Yeah, comes on you. Let's start off. So what was the last thing we did? We are doing Gauss law plates. Chalo, everyone comes on. Let's do 1-2 problems before going ahead. Hope everyone revised it. This is S1, this is S2. Radius R, let's say this charge is minus 3Q. Radius 2R and charges plus 2Q. If S1 is closed, and opened, then S2 is closed. Find final charges. Let's get this thing. How do we do this? First, you close S1 and then open it, and then you close S2. Answers anyone? See now, first you close S1. You have to do step by step. You grounded this guy. So let just as be Q. This will be minus Q. This will be 2Q minus Q. Agreed? So at this point here, potential VA should be 0. How much is that? K Q by R. K 2Q by 2R is equal to 0. We get Q is equal to minus Q. This is a charge distribution. Now you opened it. Now once you opened it, this guy became minus Q, this guy became plus Q, and this guy became plus Q. And now you're saying you're going to ground the outer shell. So this, once you ground, will charge get affected? That will not get affected, right? That will still remain minus Q. This will remain plus Q because opposite charges. Outside, I don't know, let's call it X. So this is point B now. So VB should be 0. So VB will be minus KQ by 2R because the point B is outside this shell, plus KQ by 2R is on the surface, KX by 2R, 0, X is 0. Got it? The final charge will be minus Q plus Q, 0 outside. Have a look at this. Just start to keep solving.
So net charge on the inner sphere minus 3Q will not be conserved.
No, the moment you ground, charge is not conserved.
Yes.
All clear with this? Let's see one more. Oh, make sure to revise now. These are important ones. We did something like this last time. A d theta. This is 3D. Let's say this is Q minus 2Q, 3Q. This is Q. Now, can you find the charge on each plate, each surface? We'll finish off Gauss law today. We'll start with viscosity. We will take a small break from electromagnetism. We'll finish off viscosity, surface tension, then come to capacitors. I think major test scale they have properties of matter and capacitors also. Where did they reach capacitors? Start कर लिया, करना बाकी है. Head to start. Okay. लोग क्या करेंगे रे? मतलब एक वीक पहले स्टार्ट करके खत्म कर लेंगे क्या 4 days में?
They already started.
Powai में ना?
हाँ.
Powai people are ahead. Everything goes according to Andheri. Power people don't have power. How to do this? Who is missing today? Rishi is not well. AB not well. 2 people are not well today. Okay. Three Q by 2. What's the total? Outside will be total by 2. That will be 3Q by 2. 3Q by 2. Then how are you doing that? You can't conserve like that, boss. These two plates are connected. How to do this thing? If this is X, this is also X now, because X into D is equal to X into D. The product should be same. Remember last time we did this. Q1 D1 is equal to Q2 D2. So if this is X, this is minus X. If this is x, this is minus x. If this is minus x, how much this should be? Minus x by 2, no? Minus x by 3, right? This charge into this distance should be equal to this charge into this distance. I hope you guys remember that. That's a standard result. Don't forget. Yes,
So
we
means
derived.
potential in both the plate will be equal now if they are connected by.
इसीलिए ये result है ना, q1 d1 is equal to q2 d2. Sure. Don't forget this. Without that result, it will be a pain to solve this problem. Then this will be x by 3. हो गया? If you take plate 1 plus 3, what do you get? Plate 1 plus 3 charge should be 4q. This is nothing but 3q by 2 minus x minus x minus x by 3. Add कर लेना कितना आएगा ये 4 to 8 minus 3 5q by 2 is equal to minus 7x by 3. Numbers are bad. 15q by 14. Clear? Please check. हाँ Trisha, clear ना? Nishita, got this? Amu, Divanshu, clear? Where is Ritam? Ritam भी नहीं आएगा आज. This Ritam nowadays is chilling out too much. Clear? Next one. Great. So parallel plates you understood. Now what happens if you earth the parallel plate? I will not go too much into this part, but what happens, right? Something when you have parallel plates, it doesn't matter which plate you ground, right? Now tell me one thing, what will be the charge here normally whenever you have parallel plates? If you observe, this will be q total by 2. This also will be q total by 2. And what about inside? Inside, if this is q1, this is minus q1. If this is q2 minus q2, that means the opposite plates will always have equal and opposite charges. So facing surfaces always have equal and opposite charges. So therefore, the potential energy is negative. K, Q1, Q2 by R, both are negative. That means the problem is these two guys outside, right? There is the charges on the outer surfaces are repulsive. Now, do you remember the statement? This is something which we use a lot actually. Whenever a system, right, given a chance, a system will always try to achieve a least potential energy. So when you're earthing a system, you know what you're telling the system, boss, you take how much of a charge you want from the earth, but make sure the system energy is minimum. Agreed? Now you tell me if this and this are always equal, k q square by जो भी distance है d square. What is the minimum value of this? What is the minimum value of q square? Can it be negative? Then what is the minimum value possible? 0, right? Because these two are always equal. And if you're telling the system, you do whatever you want and make it minimum. See, negative is good for me. Negative energy is minimum. Positive energies are bad. They're repulsive. So when a system is earthed, it doesn't matter which plate is earthed. When any plate is earthed, the charges are redistributed in such a way to eliminate the outside repulsive pairs because it's repulsive. Therefore, Q total becomes 0. Outside becomes 0. Got this idea? So example. That's it. This is actually pretty easy to remember the result. So if you have 3 plates, see what happens. For example, let's say this charge is Q1, Q2, and Q3. And let's say if you ground this plate, the moment you ground this plate, first thing what will happen? Normally, what we used to write, outside charge is how much? Total by 2, na? So whenever you earth a plate, you always start with outside is 0. Because total becomes 0. How much is this? You don't know. Why? Whenever you earth a plate, charge is not conserved. How much is this? Q3, na? Then how much is this? Minus Q3. Then how much is this? Q2 plus Q3. Then how much is this? Minus Q2 plus Q3. You're getting? You have to come from the side where the plate is not earthed. Example, one more. See. Let's say ये Q1 था, ये Q2 था, ये Q3 था. And let's say if I earth this, अभी क्या होगा distribution? So whenever you earth parallel plates, outside charge will become 0. And the plate which you connected charge is not conserved. What is the charge here? 0. What is the charge here?
Q1.
Q1. Conserved तो होगा. This is
Yes.
minus Q1. ये कितना होगा?
minus Q3.
You can't tell right now. 0 Q3 A minus Q3 होगा. उस साइड से आना पड़ेगा. Easy. Can you tell me this one then? What is the distribution of this guy? So whenever you earth the parallel plate, what will be the outside? 0, 0. यहाँ से start करो. Directly 0 because total is 0. Hasni, focusing. We're distracted today. And it is also lagging. What is this thing? Q minus Q minus Q plus Q. Now come from that side. 4Q minus 4Q. Please check. When you take distributions, you have to go this way and you have to go this way. All clear with this? Clear, na, Hasmi? Got this? Abhiksha, Nishita, clear? Divyanshu? Sure? Anamai? Rena, clear?
So can you repeat why we got plus Q on the left side of the grounded?
अरे ये 0 ना तो ये plus Q ना total charge conserved है. I grounded this plate, right?
Yeah, 3Q वाले में plus Q है left hand side.
Because ये minus Q तो ये plus Q है ना. Opposite faces will have equal and opposite.
Got it.
देखो ना ये 0 तो ये plus Q because total is Q. This is Q तो this is minus Q.
Yes.
But ये total minus 2Q तो यहाँ पे minus Q तो ये भी minus Q होना चाहिए.
हाँ.
Because this total should be minus 2Q ना.
Yes, got it.
Got it. Now this is a good one. I'll combine everything now. Parallel plate, parallel plate, parallel plate, parallel plate. These two are connected. These two are connected, and this guy is grounded. Sub hai. This is D. This is D. This is 2D. This is Q minus 2Q, 3Q, 4Q. Abhi bata distribution. If you got this, I think parallel plates you're clear. Any answers? See, first thing. What is outside? When you ground some plate, what is outside?
0.
0. वो तो doubt ही नहीं है. You always start from there. Then, if I call this guy x, this also will be x. X into d, x into d. This should be minus x. This should be minus x. This is minus x by 2. This is x by 2. This is all same. This is all same. कुछ doubt नहीं है. सिर्फ एक ही change था, outside 0 था. Now which plate will you conserve charge? 1 plus 3 नहीं कर पाओगे अभी.
2q plus 4q.
Because it is grounded. You can't conserve 1 plus 3 ka charge. That is the thing here. You have to conserve plate 2 plus 4. Got it? So be careful. Don't conserve the charge on a plate which is this thing minus 2q plus 4q. 2q. So this should be 2x plus x by 2 is 2q. So x will be 4q by 5. Check.
And so because one was connected to the grounded, that's why we couldn't conserve on it also.
बस हो गया. हाँ. Because the moment you grounded this, इसका पूरा charge कितना है वो idea नहीं है.
Okay.
All clear with this? I hope the parallel plates are easy and manageable. Shells and parallel plates, no? These are one important model of questions in Gauss law. All clear? Last thing. Now this is little kind of out of portion, but it's a good concept. They can always ask you questions in advance like this. We call it mirror image method. I'll just give a basic brief of it. These are the kind of questions, you know, they can always ask a small paragraph, explain you, and they can ask questions on this. Let's say we have a point charge Q here, and we have a conducting plate. Which is grounded. So if you have a plus Q charge here, what will happen? This will induce some negative charge on the surface, right? Then this charge and the plate will attract each other. So we want to find the force between the charge and the plate. Okay, so how to find this thing? Normally, how to do this thing? First of all, if you try to draw the field lines, you'll observe something. This is an infinite conducting plate, which is Earth. So when you earth something, what is the potential? 0. So the entire plate has same potential. So it is an equipotential surface. So how will the field lines be?
Perpendicular.
The field lines will enter like this, no? Isn't this how the field lines enter? Now you'll observe something. This guy kind of looks similar to if you have a plus Q and if you have a minus Q, exactly in the center. What is the potential at the center? If you have a plus Q minus Q, what is the potential at the center? 0, right? Because scalar, na? Means this entire dotted line is 0. This entire line is also 0 because it is equipotential. So agar iska field lines if you draw, you will observe the field lines will look exactly identical. Isn't it? Is that making sense? Because look at this thing. This potential is 0. This potential is 0. Plus Q, dd. The field lines will look exactly identical. Matlab, this plus Q won't understand whether the plate is attracting it or this minus Q is attracting it. Na? I get the difference. The plus Q doesn't know who is giving the field lines. Is it the minus Q on the other side or is it the plate? Are you getting it? So the field lines between plus Q and the plate look identical. Field lines between plus q and minus q. Therefore, we can replace the plate with a minus q charge on the other side like an image. So plate is behaving like a mirror, na? Infinite plate with a mirror image of negative charge. Is that making sense? So this question becomes, if you have a plus q and the distance is d, you can just put an image there. So it looks like plus q minus q and the distance becomes 2d. So what's the force between them? K q minus q by 2d whole square. Easy. Make sense? So that little minus means attractive force. But यहाँ पे ना एक catch है. What about the potential energy? Can someone tell what is the potential energy then? It will be K Q square by 2D का half. Can someone tell me why half आएगा?
क्योंकि वो चार्ज एक्चुअली एग्जिस्ट नहीं होता.
Actually charge exist नहीं
एक
होगा.
ही charge.
ना ना.
Distance between them is actually d.
नहीं, distance 2D है. Problem is only half of the field lines exist ना.
Yes.
You're getting it. Actually, only half of the field lines exist. Half of the field lines are missing. Are you getting it? So the energy is only half of it because only half of the field lines exist. Meaning it looks similar to plus q minus q, but in reality there are no field lines at the bottom of the plate, isn't it? Clear? This is how they can play around with it. Meaning, just to ask you more, suppose what if there are two plates like this and they have a plus q, क्या करेंगे then? What if you have two infinite plates? इसके लिए क्या करेंगे?
Recharges.
इसका image will be minus q. इसका image will be minus q. इसका भी mirror image form होगा ना plus q. Remember, there will be three images formed when you have a perpendicular mirror. Do you remember the formula? If you keep an object through
360
perpendicular
by-
mirror, 360 by theta minus 1. Optics में किया था. You get three images. I hope you remember that. So first reflection, second reflection का minus of minus हो जाएगा वापस. So this whole system behaves as if there are four charges like this: plus q, minus q, plus q, and minus q on a square. Then you can find the force on them. Are you sure, everyone? So this is a mirror image concept. So just keep in mind. Easy. With that, we're done with Gauss law. So there are around 25, 26 questions in HCV. Start doing them. I hope everyone, almost, I hope you finish at least 80% of gravitation by now. 80, 90% of gravity and electrostatic should have been over by now. So finish off whatever leftover pending, finish it off, and then Gauss law you can start. We'll start off with viscosity. Viscosity again is a pretty small chapter. Mostly we should wrap up by next class only. It's not much. We don't have too many questions also. And even in HCV, right, it is like viscosity, surface tension, elasticity, sub combine करके एक chapter था. So I think you will get some time, to do all of those things. So in that meantime, you can finish off this. Even though all that is one chapter, it is going to little take time. Maybe we will see. We will finish off viscosity and surface tension. Then we will see should we do capacitance or elasticity. It all depends on the pace का major test क्या है. Every year, this is every major test ये एक stunt है. Other than teaching you, I have to make a guess also what they will teach. Anyways, let's see viscosity. So again, it kind of looks like fluid mechanics a bit. But we have only like 2-3 main concepts in this. So what's viscosity? Actually, now I wanted to show you guys something. I'll show you end of the class. That will be better anyway. How was this year advanced paper? See, advanced papers now there are only two levels. One is a monstrous paper, one is a hard paper. This year paper is hard. Last year was monstrous. Mains papers are easy, moderate, hard. Normally that is a level. Bits papers are easy and moderate. So if you ask me how is advanced paper, I'll say this one, monstrous and hard. This bar hard tha. Matlab, you can you understand the questions. If you have done all the basic work, you did all my exams लिख लिया, questions solve किया notes में से. Best part क्या है ना? I think just 3-4 days before ना, I was teaching your juniors something, which I taught you guys also. ये question था. I was teaching your juniors this question. A man is walking and there is a shadow guy.
d theta by dt वो एंगल का डिफरेंस
कुछ तो था. आगे इस बार एडवांस में 2023 एडवांस में आया था ये. This is a question which I'm teaching from years. It is not like I predicted it. We do so many questions. कुछ ना कुछ एक बार repeat होगा ही. Something will come, something similar. So if you have done all the work properly and everything, this year, advanced paper physics, you could have आराम से scored around 50% marks. 50% marks, 40 to 50% marks. So maths was tough, it seems. I don't know. Physics was hard, but maths was tough, people are saying. But this year, na, your seniors did bits में really well. Some of them really did well. Highest is 346 Ekka, 331 someone, 324, 316, 313, 310. बहुत अच्छा आया था. So this year we are hoping. Last year 322 में bits plan is CS था. So this year the cutoff might actually come down a little because most people goofed up HSC boards. So they might, but still 285 bits go was CS tha. I think this year we'll have a lot of people going to bits. It's a good option. Keep working, keep working. Why bol raha hu na? See, I know it is hard. I'm definitely not saying easy chal raha hai. If you plan to do 10, if you plan to do 100, 70 हो रहे हैं ना, चलेगा. Do that 70 at least. Don't say like अरे मेरा पूरा complete नहीं हो रहा है, leave everything. Do at least at 70. Let the 30% be backlog, चलेगा. Because final exam में no one is asking to score 100%. We will try. बोल रहा हूँ ना, first mains let's give our best. First mains में if you put a very decent 98 percentile and 98 percentile के लिए you need only like 170, 160 marks out of 300. 160 to 170. You can put 98 percentile, then I think we can completely put our focus on advanced. You'll have 4.5 months time then to do. And SNI we are not doing for advanced. We are doing everything. So you have to solve more material then. Finish your HCV, finish your PACE booklet if you have time. If someone is not having time, at least HCV and मेरा notes तो अच्छे से करो. Someone is doing DCP, you can do that also. Nothing wrong. So let's see, what is this viscosity? Now, this paper was fine. It is manageable paper. If you're just careful and if you pick your questions, there are some easy questions. Aram she could have done that. So it is opposition to the relative motion. Between fluid layers in contact. This is exactly like, friction. This property is called viscosity. And the force responsible is called viscous force. So this viscosity, right, with increase in temperature, two things happen. First one, this was a direct question in the exam. Viscosity of liquids decrease. So whenever you increase the temperature, liquids flow more easily. Reason, the bond distance increases and the interactions decrease. So whenever the liquids expand, the molecules go a little far. And molecular interactions decrease. But for gases, the story is different. Viscosity of gases increase. Because for gases now, molecules are already very far. So what will happen? They start going faster and faster, so they'll collide more and more. The molecular collisions increase. Leading to more viscosity. Clear?
Means you don't like friction in liquid now.
Friction may does not depend on all temperature and all. No? Matlab, in solids we call it friction, in liquids and gases we call it viscosity.
Huh.
Clear? Then first concept here, Newton's law of viscosity. To consider a plank moving on a fluid layer with speed v. Let this area be A. Let this velocity be V. So this viscous force will be backward. And this depth of the lake is Z. So this viscous force is given by minus eta A dV by dz. This is the formula. This eta is called coefficient of viscosity. The units are poise. There is a problem here. 10 poise is 1 SI unit. Poise is not an SI unit, it is a CGS unit. Meaning, if someone says eta is 30 poise in the question, we have to use 3. We have to use eta is equal to 3. Be careful. Agar 30 use kar liya, exam mein there will be two options, like 0.2, 2. There will be always a factor of 10 ka difference aayega. That will goof up everything. They do these kind of things in bits and mains. A is the area in contact with liquid. This quantity dV by dz, anything that changes with position is called gradient. So this is called velocity gradient. Let's see what is our velocity gradient. We'll discuss in more detail in the next page. Have a look at this. Clear? Now, what does this minus sign indicate? The negative sign indicates opposition to relative velocity. Understand one thing, all viscous forces, right, friction and everything, they don't oppose velocity. They always oppose relative motion. Then, what is this dv by dz? So this dv by dz actually, right, delta v by delta z is the relative velocity between two layers. Distance between two layers. So when this liquid is flowing here, if you take a layer here going with V1, and if you take a layer going with V2, and if this distance is Z2, and if this distance is Z1, you can take this thing as V2 minus V1 by Z2 minus Z1. But the problem is, use this only for thin layer. If the layer is thin, you can use this, or else this is not valid. It's not a linear function. Okay. And one more thing, when you write this formula, F is equal to minus eta A dV by dz, can I call this quantity F by A? Is this pressure? We know force by area is pressure. Is this pressure? Why?
Pressure is
It is
always
not only
perpendicular to the
Pressure का definition था force perpendicular to surface area. This force is how? Parallel to
parallel.
area ना. ये pressure नहीं है. F by A is not pressure. Since F is parallel to area. Clear? Clear, everyone? This is one. Then we have few more assumptions here. Did you ever observe this thing? When you see a fast moving river, if you see fish inside, you'll observe no matter how fast the river goes, the fish at the bottom are happily swimming.
Yes.
The reason is, we assume the fluid layer in contact with the solid has the same velocity as the solid in contact. So when a river is flowing, right, the ground is at rest. So the water which is touching the ground is almost at rest. So the last layer which is touching the ground is almost at rest. So the upper layer is going the fastest. So if you take a river flowing, this is what you'll observe. The bottommost point almost has zero speed. If you go little up, it will increase. 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 This is how the speed goes. So the higher up, the faster you go. That means whenever the fish wants to go down the river, it will swim on the surface. Whenever it wants to go opposite to the river, it will swim at the bottom. So this is a velocity profile of a water in a lake. Can you tell me how will the water flow in a pipe? Now here, where is the solid? Circumference. No? So this point velocity will be 0. This point velocity will be 0. So it will be like this, 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 this. So if you actually draw them, you get a parabola.
Sir, what is
Neglecting gravity. So this is the velocity profile of a water flowing in a pipe. That means whenever a water flows in a pipe, the center part will go the fastest. The edges will go the slowest. Think about it, when you put ketchup, kaisa aata hai? The ketchup in the middle comes out. The edges will be sticking to the glass, right? You have to put your finger and take it out. कभी नहीं खाया? Imagine your jam bottle, right? You're putting the jam down and last jam thoda bach gaya. What do? You take the bread, put it inside the jam cup bottle, you rub everything and eat. Never did that. Nutella, chalo jam nahi hai. Nutella you must have done, I'm sure. Now pura clean kar lete andar, right? We will just put the bread piece inside, we'll rub everything and eat. So there. That is because it gets stuck on the edge. Rena is saying, I'll buy a new bottle. I don't do such things. Nahi. So how does this thing look like?
Sir, if I move the pipe, then it won't be zero at that point.
It won't be zero. So basically, idea is you made a hole filled with smokes. When you hit it, the smoke comes out, right? So ideally speaking, kya aana chahiye? You should get a cylinder of smoke, right? But see what happens. Dikha ring. What is happening? The edges are going slower, the center is going faster, na? So if the center part goes away faster, kya hoga? You'll get a hole. Isn't it? If the liquid is flowing, the air is flowing, the edges are going slower, the center is going faster, you get a hole in the middle. So this is what happens. Did you ever see Tom and Jerry mein? Sometimes Tom will take a cigarette and smoke that will release rings. Kabhi dekha? Tom and Jerry mein? So ring ka concept yahi tha. You are using the mouth, right? And you're releasing smoke. The edges will go slower, the center goes faster. It's called a vortex cannon. This thing you have seen here also.
Oh, Toby, the finest weed in the South Valley.
Now see, this is physics. This is magic. ये viscosity नहीं है.
Gandalf, my old friend.
There. Did you see? So when you're watching Harry Potter, what I am looking and what you are looking. That's the difference. So he's talking about Gandalf Rundle. मैं सोच रहा हूँ, oh, viscosity का ring था. Side effects of being physics teacher. So there. Clear? So got the idea. So there's only one formula I taught you till now. F is minus eta A dV by dz. Okay? Let's see a question. So we have two fluids here, two surfaces. This is a good one. The upper plate is going with 2V. The lower plate is going with V. Both the plates are going into opposite directions. Here the floor is not at rest. This center is completely filled with a fluid. Viscosity eta. Somewhere in the middle, you kept a plate. You getting how is the plate? It is parallel to this surfaces. So means it look like this only. It's a plate. So this plate is pulled with force F and it is also going with speed V. This distance is 2D and this distance is D. So the question is, and this area is A. Find F to pull the plate out of the liquid with a constant speed V. To pull the plate out with constant speed V. Are you getting this question? So if you have a plate in the middle and if you're pulling it out, right, there'll be how many friction forces here? How many viscous forces will be here? 2, right? One on the top and one at the bottom. No, there are 2 contacts, no? A floor or A floor ka contact. This and this ka contact. So let me just draw a little thick. I hope you're able to visualize how it is, the diagram. If you look at the side view, now it looks like this side view. See, the plate is like this in the middle, and you're pulling it out like this. Able to visualize how it is? It's like a parallel plate. This plate is here, and this plate is here. Able to visualize? Yes, all are parallel to each other. This guy is going with 2V, this guy is going with V, and this guy is going with. In the beach, it is fully filled with fluid. So with how much force should I apply so that it comes out with a constant speed? Try, I'll give you a minute. We'll finish for the major part today. Next class, we will wrap up most of it and we'll start surface tension. Like I said, it's a very small chapter. Concepts be difficult. There are only 2-3 main formulas which you need to remember. Put it on. Today, end of the class, I'll show you something. Binary stars, how to make a binary star. I found a game. In that game, I made the mass of the Jupiter equal to 3 times the mass of Sun. And the Sun started rotating around the Jupiter. Then I made the mass 1,000 times. Jupiter became a black hole. There's a game called Universe Sandbox. I know that game, it was long back. It's not a game exactly. It is like a universe simulation. You can do all nonsense in that. How do you do this? Think for a minute. Think for a minute. Your juniors are, meaning your JE advanced juniors are okay. I got medical ka juniors. God level are they? मतलब God level, मतलब God level. I gave this equation, sine 60, sine square 60, sine cube 60, so on till infinity. What is this? Infinite GP, na? By tan 30, tan square 30, tan cube 30, so on. You know what they did? Can you guess what they did?
Sir, I thought they did something cos.
Nah, क्या बात है बोलो? Sine 60 by tan 30 plus sine square 60 by tan square 30, sine cube 30 by tan cube 30. I was just staring at क्या कहूँ मतलब, and not one person, 3 people did that. Gatko for the medical batch 2 days back. I was thinking, ठीक है यार, I know you are medical students, doesn't mean इतना भी dumb नहीं होना चाहिए. There is another great god, 2 sine theta by 2. You know, you can guess what it did. कैंसर का लेफ्ट कैंसर करके साइन थीटा बोल रहा था. तो ये फिर भी there is another guy, sin A plus sin B. I hope you can guess what they did. Sin common ले लिया, A plus B कर ले. कुछ भी कर रहे पता है वो लोग. Anything they are doing, Max. ये सब हाईलाइट है. मुलुंड में there is one guy, he is asking Pythagoras theorem क्या होता है. I don't know, so that was heights actually. Chalo, telling you now, teaching you guys is more easy. When I teach them, I lose my mind sometimes. They're kind of innocent, Ray. They're just too jovial. They're not serious about life and too innocent. They become damn serious in 12th standard, when they realize. Because engineering and medical ka difference kya hai na? If you don't get a medical seat, you just have to pay 1 crore for donation and you'll get a seat. Problem wo tha. 1 crore donation, fees nahi hai. They have their own problems. Some people become very serious and study. What to do this thing? See what is happening here. No, medical, that's why I don't teach everything. I just teach one track. I have other teachers who handle other things. I just take mechanics, kinematics. They find kinematics more tough than rotation. Let's see what is happening here. First thing, this plate is there. This plate is there. No, it is fun to teach them though, in a way, because I connect a lot of physics to biology for them. So this is V, this is 2V. Can you tell me which way will the viscous force be? First, A important. Most people goof up. They put F backward. Who is going faster, 2V or V? 2V, na? To whom should you support? This guy, right? Viscous force is opposite to relative velocity. It is not opposite to velocity of the body. Think like this thing. Imagine local train station, you got down and you're walking with the crowd. If you're walking faster than the crowd, what will the crowd do?
Push.
They'll push you back, right? Suppose if you're walking slower than the crowd, what will the crowd do?
They'll push
They'll
forward.
push you forward, na? So if you're walking slower than the crowd, the viscous will act forward. It will make you go faster. Viscous force ka job is not to stop you. Viscous force ka job is to make sure relative velocity is same. What will this friction do? F2, right? And this guy will be F. So you're done. So basically F plus F1 is equal to F2. F1 will be how much? This distance is D and this distance is 2D. So F1 will be eta, area, relative velocity between the layers, that is 2V minus V by distance between them. F2 will be eta A, relative velocity is V minus of minus V by 2D. This thing will be eta A V by D. This also is coming eta A V by D. Luckily both are equal, so F is 0. Means you need not apply any force, it will go automatically on its own. If I can change the numbers, I'll get a different answer. Please check, easy. I didn't understand the brain. The end of the class, you can ask me. All clear with this? Go ahead. Next one. The main catch is this. What most people do, they write F1, F2 both backward. That is a mistake you do. Be careful. Next one. We have a long incline. On this incline, we have a thin layer of fluid. Whose thickness is Z. On top of this layer, you have a plank. Mass M, area A. Viscosity of this plank liquid is eta. Initially released from rest. So what will happen? This will slide on the plank, right?
Yes.
Find velocity of the plank as function of time t.
Sir, viscosity का एक बार formula दिखाओ ना.
What you're doing till now, drunk? I told you to write it down. एक formula था. Eta A dV by dz. If you keep
Those
the
are next
plate with the
next page.
vertical.
Yes, sir.
Get this thing, everyone. It's a good one. If you give the plate at some angle theta with the vertical with the plate, rotate. हाँ ना? हाँ Harsh, but that will be different forces ना. Rho A V square. Remember water jet वाला वो आ जाएगा. That is not viscous force. How do you do this thing, everyone? Try, it's a good one. Little integration is there. First draw the FBD from there, you'll get it. How do we approach this? See the forces, whether you got this or not. Mg sine theta, viscous force F, which is eta area dv by dz, that is v by z. You're taking which 2 points? You're taking this surface ka velocity and you're taking ground ka velocity, isn't it? Ground is 0. And the distance between them is z. And the acceleration is a and the velocity is v. So see what is happening here. As it is going faster and faster, viscous force also is increasing. So at some point, the viscous force becomes so strong, it will balance mg sine theta and velocity becomes constant. Getting it? So if you write the forces here, you get mg sine theta minus F is equal to ma. This will be mg sine theta minus eta a by z v is equal to mass into acceleration dv by dt. So you can write this thing as dv by g sine theta minus eta a by mz v is equal to dt. Integrate on both sides, 0 to t, 0 to v. I hope you know this integration. Dx by ax plus b का integral is 1 by a ln ax plus b. Calculus start हो गया? Integration.
Yes.
Fine now. Even if you don't know, so that is the thing. So यहाँ पे a is this guy 1 by a, so this will be minus mz by eta a ln g sine theta minus eta a v by mz 0 to v का limits is equal to time. So v will be mg sine theta z by eta a 1 minus e power minus eta a time by m z. This is what you get velocity as function of time t. It's an exponential function. I'll just turn back. So if you try to plot the graph of v versus t graph, velocity is 0 and eventually it becomes constant. It will tend to a constant value. This is called v terminal. The final velocity which you reach is called v terminal. So when you reach v terminal, acceleration is 0. So this thing simply becomes, if you just want v terminal, na, put this 0 na, directly v aa jayega yahan se. Keep that in mind. If you just want v terminal, you need not do all this integration. Directly acceleration is 0, yahan se v ka value aa jayega. So this guy would be mg sine theta z by eta a. That is your terminal velocity. Just to give you a little more information, suppose if they ask you to plot AT graph, this is an AT graph, acceleration versus time graph. This would be a VT graph. So velocity is always increasing, acceleration is always decreasing. Please check the integration. How is mg sine theta minus f is I didn't understand, Rajni. Bolo na.
Sir, I was asking why is mg sine theta minus f is equal to ma?
Arey, net force is mass into acceleration, na? Along the incline, what are the forces? Mg sine theta minus friction. Force is equal to mass into acceleration.
Yeah, got it, sir.
No? Sure? Dokho na, meaning if I keep a block here, if I say this is mg sine theta friction, how will you find acceleration? Mg sine theta minus friction is a net force in this direction.
Sir, got it.
Net force is mass into acceleration. All clear with this? Please check. Clear? Next one. Please check the graph also. Clear. Next one. This would be a good one, right? So let's say we have a surface here and we have again a thin layer of fluid. On top of it, someone kept a plate and they rotated with omega. Disk of mass m and radius r. Able to visualize how it is? So you kept a rotating disk on a thin liquid.
सर रोटेशन में ऐसा किया था ना टाइम बंद निकालो जब बंद हो जाएगा उसको
Yeah, rotating disk किया था, rotation में similar किया, but it is on a ground there. It's
हाँ,
placed
yes.
on a thin layer of fluid. Viscosity is zeta. Find omega as function of time t. Find the angular velocity of the disk after time t. Get this thing, everyone. This is an advanced question. Meaning, if someone is wondering what is this, this is what we did in rotation. Mein somewhere we did.
सर लास्ट में
Okay, somewhere we did. Let's do this thing. It's a good one. This is even better than rotation question actually. Try. 3 minutes. It's a good one. Just think how will you do. Just give it a try and let some water and come. How do we approach this? The problem is what? When you write B by Z, every point has a different velocity, right? So see, this is how we choose an element. So when you take this ring from the center at a distance x, take a thin ring. This ring is going with a velocity x omega. So if you just draw this one ring here, this ring is going with x omega. So on this ring, the friction force will be backward. So what will be this friction force? F tangential. So this entire friction will be like this. Agreed? Opposite to the ring, no? That will be eta. Area of the ring is 2 pi x dx. Velocity of the ring is x omega by z. Z is the distance between the ring and the ground. Yes? dv by dz. So what is the torque on the ring? Now you can't integrate this. You have to get the torque on the ring. Torque on the ring will be x into force on the ring, which is 2 pi eta omega by z x cube dx. So this is the torque on each ring due to the viscous force. What is the torque on the disc? Add all the ring torques. That will be 2 pi eta omega by z integral x cube dx from 0 to r. That would be 2 pi eta omega by z r power 4 by 4. This is the torque. Pi eta r power 4 by 2z omega. Please check till here. So this is the total torque acting on the disc as function of omega. Means the faster you rotate, more torque. And observe one thing, r power 4 tha. Means if you take a disc of r and 2r, that 2r disc is 16 times more difficult to rotate. So the bigger the disc you keep, it becomes to the power of 4 times difficulty. Clear so far? Hasni, clear, na? You look tired today. Laddi, got this? Nanya, clear, na? So far, Geet, Anamai, Kavya, Ritam. So after this, what to do? The torque I got pi eta r power 4 by 2z omega. Torque is nothing but I alpha. I is nothing but mr square by 2. Two goes off. We get alpha is equal to pi eta r square by mz omega. What is alpha? Minus d omega by dt, because it is decelerating. Again integration, double integration actually. First time you integrate with x and second time you integrate with time. D omega by omega is equal to minus pi eta r square by mz dt integral. Omega initial velocity to final velocity 0 to time. This will come out to be ln omega by omega naught pi eta r square time by mz. So the disk will never stop. Actually, it takes infinite time for the disk to stop. Please check this thing, the top part.
So this is the derivation for the result we got at the end of SHM, right?
नहीं वो अलग है. वो किसके लिए था? Torsional torque था वो. That's for twisting the cylinder, ना? वहीं पे liquid and all nothing was there. It looks similar though. It looks similar. वही आएगा वहीं पे, but I know what you're saying. Check everyone. Is this clear? This is a good one, right? So generally, this is the first part of the chapter, okay? The viscous force, Newton's law of viscosity. This is the level they can go. You can just now keep playing. Idea to wahi hai. Main idea All got the steps. First find the torque, get alpha in terms of omega, and then you integrate. Because the torque is also not constant. If the disk is going slower, torque is also lesser. So the slower the disk goes, the lesser the torque you require. All clear with this? Can I turn the page? Next thing. Poiseuille's equation. Poiseuille's equation, what it says is, suppose if you have a pipe of radius r, let's say the pressure is P2, pressure is P1. The length of the pipe is L. Liquid is flowing inside. Viscosity is eta. Now tell me one thing. If there's a viscosity, the liquid won't flow on its own, right? You have to apply some kind of pressure or else the liquid won't move out. So the volume flow rate, that is the amount of liquid that is flowing per second. The flow rate dV by dt is given by pi delta P r power 4 by 8 eta L. This equation is called Poiseuille's equation. And see what is saying. If the radius is big, more liquid will flow. If the length is big, less liquid will flow. Delta P is the pressure difference. I think you should note down this formula. In physics, it is one of the rare formula where you have a power 4. Where did you see power 4 before?
In the question वो जिसमें पैराबोला सब लोग बोल रहे थे आंसर और उसका आंसर x की पावर 4 आया था ना.
Keep wait. Which concept? Where did you see r power 4? There is one formula where you see r power 4. तो some problem बोल रहे हो. वो ठीक है, understood.
Square cube, that cube square law.
मेरे हाँ शौर्य power 4 formula.
क्वेश्चन ही याद है.
Seriously, no one remembers power 4 कहीं पे आया था फिजिक्स में? Stephen's law, gods. Sigma I T bar 4 minus TS bar 4. भूल गया क्या Stephen's law? Power 4 था. Power 5 कहाँ पे आएगा याद है? Power 5, where did you get it? ये याद है Wien's displacement law? This peak ना is proportional to T power 5.
अच्छा हाँ, lambda to t constant.
वो lambda into T constant वाला. Wien's displacement law में the peak of that
Yes.
thing is proportional to T power 5. Power 5 is pretty rare. 1 by r power 4 कहाँ पे देगा? Drunkard.
और ये तो वो dipole interaction में वो
dipole forces भूल गया. 6 kp1 p2 by r power 4.
हाँ केमिस्ट्री में बता.
Dipole forces. Gods, भूलना मत. यही होगा. Simple questions will come like this and you'll go up and come. Copied the formula. So this formula, if you see, right, it looks something little like, this. So d volume by dt, this can be written as delta p by pi r power 4 by 8 eta L by pi r power 4. If you see this, it kind of looks like I is equal to V by R. This looks like current, na? Volume flow. This is pressure difference, looks like voltage difference. This is looks like resistance, right? We did this in heat transfer. Anyone remembers thermal resistance का formula क्या था? Thermal resistance ka formula, everyone. If you have a rod length L Ka, what is the thermal resistance?
K by
K L1 by A.
What is thermal resistance? Shankards, bhul gaya. L by Ka. You can
reciprocal
replace
volt.
the rod with the resistor L by Ka. See, array, you guys can forget complex problems. Right? Basics you forget, that will be a problem. Revise, make sure. Abhi hai. Next test is what? Fluid and SHM. Uske baad, I'm going to put some thermodynamic practice papers bhi hai. You can try. So basically, this R, right, resistance is 8 eta L by pi R power 4. So basically, this is the resistance to flow. Meaning, if you got a pipe, you can replace that with a resistance R, which is 8 eta L by pi R power 4. So resistance R and length L and eta. Do note it down. Means sub aayega bhi. Series, parallel, whatever you did in heat transfer, it will come everything. Exact same things. Only difference is there it is a heat flow, here it is a water flow, liquid flow. Note it down. Clear? So
Sorry.
when do you say two pipes are in series then? Resistance mein for series, what is the condition? Same heat flow. So here it will be same volume flow. If you have two series, it should have same volume flow. So if you have a pipe, and if you have a pipe, you can just treat them like two resistors, R1 and R2. So R equivalent will be R1 plus R2, where R1 will be 8 eta L1 by pi R1 power 4. R2 will be 8 eta L2 by pi R2 power 4. For parallel, same potential difference, here it will be same pressure difference. You can just treat them like two resistors, R1, R2. 1 by R equivalent is 1 by R1 plus 1 by R2. Check. Everything written heat transfer works exactly same. So every model you need transfer, you can apply. The rods and everything especially.
Sir, is it the volume flow at point of intersection? ऐसा कुछ है?
कुछ नहीं है. Volume flowing through the pipe. क्या intersection? Don't
नहीं,
create new stuff.
नहीं, जहाँ पे दो पाइप मिलेंगे उस पॉइंट.
कहाँ पे मिलेंगे? अरे what is entering should leave ना रे God. क्या बात कर रहे हो? A1 volume flow is constant, right? Whatever enters has to leave. Na, where will the extra water go and stay then? Do you guys remember Wheatstone Bridge?
Oh yes.
क्या था? So if you have a resistor, 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 and resistor, R1, R2,
We can cancel the
R3,
middle.
yeah, R4 and R5. If R1 by R2 becomes equal to R3 by R4, then R5 can be removed. Check this. Clear? Let's see some questions on this. Poiseuille's equation, they can ask like this also. In Poiseuille's equation, which quantity has to be measured carefully to decrease the error? Which quantity? In Poiseuille's equation, which quantity has to be measured carefully in order to decrease the error? Pressure, length, radius, eta.
और radius because अगर हल्का सा भी error होगा तो
Radius.
बहुत बड़ा exponential.
Radius to the power 4. अगर उसमें error ज़्यादा हो गया तो error will magnify a lot. This was a CET equation. Let's see a question. We got a pipe connected to another pipe in series. This radius is 2r. This radius is r. Here the pressure is 2p naught and the pressure is p naught. The liquid is flowing through them. Eta is viscosity and this point is the interface. Find R equivalent, volume flow per second, how much volume is flowing through the pipes, pressure at the interface. Is this question looking like this?
सर यही बोल रहा था इंटरफेस पे जहाँ पे कनेक्ट होंगे दो पाइप.
Yeah, this is the same question there. Chalo, try. Chalo, Shaurya, try karo. Who left? Someone left. Who is? Looks right. So the first thing, this is a resistor R1. What is the formula? 8 eta length L. I forgot to give, lengths are same, okay? By pi 2r whole to the power of 4. R2 is 8 eta L by pi r power 4. For simplicity, right, what we will do, let's call this thing X. Then this will be how much?
X
X
by
by
16.
4, no? 16, right? So what is R equivalent? 17x by 16.
Power.
What is volume flow? Volume flow is nothing but pressure difference by R equivalent. That will be P naught by 17x by 16. How to find the pressure at the interface? So resistor, this is X by 4 and this is X. Just
Sir,
like current
equal time.
variable. Yeah, equal
Equal.
time. This is 2P naught and this is I and this is P naught. So here the I current will be 2P naught. Let this pressure at this point be P dash and this be P naught. So this is current I and this is current I. So I will be pressure difference 2P naught minus P dash by x power 4 should be also equal to P dash minus P naught by x. See, whenever you want to find the pressure at the interface now, we don't need the exact values. We just need ratios. X and X will cancel. You end up with 4 into 2P naught minus P dash is equal to P dash minus P naught. 8P naught. That will become 9P naught is equal to 5P 16 hai na? That was 16. That will be 33P naught is equal to 17P dash. So P dash will be 33P naught by 17. Please check. Huh, Kavya? Clear? Shaurya, got the same?
Yes, sir.
Nishita, Reina? Clear? Labdi?
Yes.
Check. Understood what we did? We found the current in this should be equal to current in this because they're in series, obviously. We did the same thing in heat transfer also. Next one. Can I turn the page?
Yes.
I hope you remember this one. Y shape. So here the pressure is 3P naught. Here the pressure is 2P naught. Here the pressure is P naught. So here it is length L, radius R. This is length L, radius R by 2. This is length L and radius 2R. This is the interface. Find the pressure at the interface.
Sir, if the pressure is different, that means both the ends, equation of continuity is not valid. No?
Q, why it is not valid?
It's a valid. Okay.
Equation of continuity simply incoming is equal to outgoing. उसके लिए pressure का कुछ फर्क ही नहीं है.
Okay.
Get this thing? Again, I told you this question will come. I'm telling you again, this question will come 2 more times. Remember this one? Y-shaped rod. Exact heat transfer questions था ये सब. This will again come in capacitors. This problem you will see in capacitors. उसमें I'll ask you like this 3 capacitors. This will again come in resistors. I'll ask you in 3 resistors. This question comes in 4 different chapters. Idea is the same in everything. Try. I'll give 2-3 minutes. Try. Again, remember, whenever I ask you pressure at an interface, I don't want the exact values of resistance. इसका अगर R assume कर लिया, give it everything in terms of R and finish it off. Try. 2 minutes. See, first thing now, let's define R will be 8 eta L by pi R power 4. That means that guy will be how much? 8 eta L pi R by 2 power 4 will be 16 times R. Numbers will be bad, right? Pi 2 R power 4 will be R by 16. Means your whole circuit is like this. R, 16R and R by 16. Agreed? This is how the whole thing looks. R, 16R and R by 16. So at this point, if the pressure is 3P naught, let's call this pressure P dash. This is 2P naught and this is P naught. So if you assume this current is I, this current is I1 and this current is I2. You can see from junction law, the current inflow is equal to current outflow. Agreed? So current is flowing from 3P naught to P dash by resistance. I1 will be P dash minus 2P naught by resistance. P dash minus P naught by resistance. Numbers are bad. R cancels off. 3P naught minus P dash is P dash minus 2P naught by 16 plus 16 times P dash minus P naught. Calculate from here. P dash aa jayega. Please check. Numbers are quite bad. She got a very big number. 302 by 256 P naught, it seems. Check. I hope the steps are clear. Clear?
Sir, 1.12 P naught आया. 1.120 P naught equal to P.
ठीक है. चलो, we'll leave the working to you. Next one. We're getting how is the liquid flowing? This is how the liquid is flowing. All rods are identical. L and R all have same this thing. So this point the pressure is 2P naught and this point is pressure is P naught. A, B, C, D, E and F. Find R equivalent, volume flow and pressure at B, C, D, E. Let's get this. Yeah, it's a bit strong. Get it. Try 3 minutes. And the best part, I'm sure we did this also.
Yes.
Same question, dekho. Find R thermal, find heat flow, find the temperature at BCD. These kind of questions are quite important because they come in multiple chapters. It actually, you just revise one, you get everything. Circuit first is R. This is a Wheatstone bridge. So the center one can be removed. So this is R, 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 and R. So these two are in series, 2R, 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 R is R, and RR will be there. This will be R by 3. Got this? Volume per second will be pressure difference, 2 P naught by R by 3. वो भी आ गया. How do you find the pressures at BCD? Think, I'll give you a minute.
So equivalent resistance is 3R now.
3R होगा. You're right. See. So if you assume current I is flowing here, this will be I by 2, this will be I by 2, I by 2, and I by 2. So this point ka pressure is 2 P naught. So A, B, C, D, E, and F. So this guy is P naught. This guy is 2 P naught. So when you write from A to B, so the current I will be 2 P naught minus PB by resistance R. I is nothing but, just now we calculated it, P naught by 3R. So RR will cancel, PB will be 2 P naught, 2 minus 1 by 3, 5 P naught by 3. Understood what it is? Just you have to take for each section. Now when you take from B to C, current will be I by 2. This will be PV minus PC by R. So I by 2 is nothing but P naught by 6R. PV is 5 P naught by 3. PC by R cancel hoga. PC will be 3 P naught by 2. Because of which from which PC and PD will be equal. Then when you take E to F, I will be PE minus PF, which is P naught by R. यहाँ पे PE आएगा 4 P naught by 3. Check. Clear? Now there is one last part in this thing called Stokes law, which we'll do in the next class. It's a small topic. I think it'll take another half an hour, 50 minutes. We'll wrap up with that. And then we'll start up with surface tension. But like I said, the chapter is pretty small. There are only 3 concepts in this. Newton's law of viscosity, Poiseuille's equation, and Stokes law. But did you observe this Poiseuille's equation looks exactly like heat transfer. Conduction jaisa. The Newton's law of viscosity is still a little difficult. That is a more major thing. Clear with this? So that is one. I just wanted to show you something and then we'll wrap up with that. Can you see? This is actually simulation of this entire solar system. Okay, now you can see that planets orbiting. You can see all elliptical orbits. Now you can see the Earth also. That is Earth. So what we'll do now, we'll mess with Earth. So this thing now, you can actually change the data of where are you, Earth? There. There. You can see the table on side. You can change the values of the Earth and everything. So here, right, I can change the mass. If I make it 10 times, nothing much happened because Earth is actually, massive. Sun is massive. This music is too much, right? I multiply by mass by again more. Now Earth is almost 100 times more massive. You can actually observe the other planets are getting messed up slowly. I'll make Earth even more massive. Did you see Mercury and Venus are getting messed up? You can see. Can you see now Sun and Earth are rotating about each other? Now the mass of the Earth is almost 0.3 times the mass of the Sun. If I just double here, the Sun got messed up. See, Sun and Earth are rotating about each other. Now the masses are comparable. Now you can clearly see here. See, can you see Earth and Sun are rotating about each other? This is the Earth. It became a binary star. Now there's something happening with the Earth now because Earth ka mass became so much. If you make the Earth ka mass even more, Earth is becoming a neutron star. If you make it more massive, Earth become a black hole. You can see all the orbits are getting messed up. Everything will get. Sun went away somewhere. See, Sun is flying off. Sun went away somewhere.
But it is showing Earth became a star.
Earth became a black hole actually. That's a game. It's a nice game. So once you make the mass double, right? Sun started, Earth and this thing will start rotating about each other. Okay, with that we'll wrap up for that end. The game is called Universe Sandbox. I brought it for 400 rupees. Steam में. It's a good game.